Welcome to Chopra's School of Physics. As we have done in our first 10 videos, a lot of things about electrostatics. We have discussed about the permittivity, the Coulomb's law, and many other formulas like potential, electrical potential energy, capacitance. Now, this time we have to review more about the basic concepts like positive charge and negative charge, what is their characterization, why electron is supposed to be a negative charge and why proton is supposed to be a positive charge, and what exactly we know about the region around the charges, whether it is a positive charge or it is a negative charge. So, first of all, we have to understand how much force is applied by the stationary charges and the moving charges. Which charge will basically apply the force and which will be the receiver of that force. So these facts we have to go through. What is the Lorentz force and how it is applicable to our numerical applications. So these facts are rather very basic facts. And the source which we are using here is the book from National Council of Scientific Research and Training. That is in small, it is NCRT. So I'll tell you that charge is an agent which either emits electrical lines of forces or gains electrical lines of forces. And when we speak electrical line of force, it is a path of the unit positive charge. And unit positive charge is either 1 Coulomb charge in MKS system or SI system, or it is 1 electrostatic unit of charge or 1 stat Coulomb in CGS units. So here, it will be more clear from the figure. Now, suppose that we consider here a point and this point is emitting like this electrical lines of forces. This is the pattern of the lines of forces given out by a charge. And you are observing arrows are indicated outward. This is a point charge. And this is emitting lines of forces. This charge is supposed to be plus Q. And we will write here Q greater than 0. Now, any of the question when we write Q greater than 0, that is supposed to be a positive charge. So it is Q greater than 0, it is a positive charge, it is generating lines of forces. So what is the main characterization of a charge? Emitting electrical lines of forces. If it is emitting lines of forces, it will be a positive charge. As it is shown in the figure, it is Q greater than 0. And if we draw like this, there is a point charge. We draw lines of forces like this. These are the pattern of the lines of forces. And the arrows are inward, like this. So here, charge is receiving the lines of forces. In this case, the charge is emitting out, emanating the lines of forces. So it will be a negative charge, minus Q, or we can say Q is less than 0. So positive charges are those which emit electrical lines of forces, and negative charges are those which receive or gain electrical lines of forces. Mathematically, we write Q greater than 0 for positive charge and Q less than 0 for a negative charge. Now we have come to a very important argument why proton is a positive charge and why electron is a negative charge. When we speak proton, we write like this, that is plus E. And when we write minus E, this is supposed to be electron. So this is called proton, and this symbol is for electron. So these are the two symbols. Why we are saying proton as a positive charge? Its characterization is emitting lines of forces. That's why it is positive. So plus E is generating lines of forces like this. So it is a positive charge. This is the pattern of the lines of forces of proton. And this is the pattern of the lines of forces by a negative charge, that is electron. So electron is indicating like this type of lines of forces, and proton is indicating this type of lines of forces. Now you will further remember that when lines of forces are moving in three-dimensional region, like lines of forces are moving like this, that is along x-axis, along y-axis, and along z-axis. That is the lines of forces that are distributed in a given volume around the charge. This crowd of the lines of forces around a charge in a given volume, that is what known as electric flux. So the point to remember, what is electric flux? Electric flux is crowd. Electric flux is crowd of electrical lines of forces. Electrical lines of forces around the charge in a given volume. Electrical lines of forces around the charge in given volume. So this is how we define these lines of forces. This crowd of the lines of forces is called electric flux. So now you can review: positive charges emit lines of forces, negative charges gain lines of forces. Proton is a positive charge because its tendency is to emit lines of forces, and electron is a negative charge because its tendency is to receive lines of forces. The crowd of lines of forces around a charge in a given volume, that is called electric flux. So I hope this is clear to you what is electric flux. Now, if we write like this, that is plus minus Q or plus minus E modulus, it will be plus E, or minus E is also written as plus E. So when you write like this, it is magnitude of charge. Magnitude of charge of electron and proton, and its numerical value 1.6 10 to the power minus 19 Coulomb. If you wanted to convert it to CDS units, I have already explained that 1 Coulomb is nearly 3.3 10 to the power minus 10 ESU of charge. ESU of charge. So this is nearly 1 coulomb is this much, or you can take approximation 3 into 10 to the power minus 10 ESU. So we can convert it to CDS. 1.6 is multiplied by this number, 10 to the power minus 19 multiplied by this number, and the number will be transformed into CDS. So this is about the positive and negative charges, and there is a reason why proton is a positive charge and why electron is a negative charge. But now we have slightly a different definition that what is a positively charged body and what is a negatively charged body. So if there is an atom, the point to remember is that every atom has a central part, and that is called nucleus. Around the nucleus there are a lot of orbits, and orbits accommodate electrons. When we supply energy to the atom from some external source, then there are chances that electron will be emitted out from the atom. In this situation we say that atom is ionized. Now, whenever a body loses electron, we will find its positivity goes on increasing. So all positively charged bodies are those which are deficient of electron. And if there is excess of electron on the body, it will be negatively charged. So positively charged body, when we speak, positively charged body. Positively charged body, deficient of electrons. Deficient of electrons. If a body has excess number of electrons, it will be negatively charged. So it means that charged bodies are of two types, like there are two types of charges, the positive and negative charges. The positively charged bodies are those which lose electrons, which are deficient of electrons, and negatively charged bodies are those which has excess number of electrons. So there is a main difference in the two types of bodies. So if electron is given out, it means some mass is also lost by the body. If mass is lost by the body, it means that mass decreases. So positively charged bodies have got the mass, but their mass is slightly less as compared to negatively charged bodies. So what is the point to remember now? Positively charged bodies have more mass, less mass as compared to negatively charged bodies. So now I am writing here mass of positively charged bodies. Positively mass. M is mass. Mass of positively charged bodies. Is always less than mass of negatively charged bodies. In this concept, you have to remember mass of electron, that is 1.6 10 to the power minus 31 kilograms. No doubt that this mass is very small, but with respect to nucleus or with respect to atom, this mass is very significant. We have to consider. So that's why when positively charged body we say it is losing this mass per electron. So if it will lose the mass, obviously the mass of positively charged body will decrease and the mass of negatively charged body will increase. We can say inertia of a positively charged body less than inertia of a negatively charged body. This mass is related to inertia. Wherever we say inertia, it means we are referring to mass. So I hope this difference is clear to you. Now another important point is that lines of forces are given. For a particular charge, the lines of forces are spread in a given volume. In a given volume, there is lines of forces, they are extending to a certain limit. Not that a charge is kept here and its effect is felt about 40 kilometers away. That's not possible. So every charge has a restricted or a limited field. So the region in which the lines of forces exhibit their effect or showing their effect, that is called electric field. When we plainly speak electric field, we write like this. So you will remember that the lines of forces, they are spread in a certain region. One important point, the line of force is that in which unit positive charge moves. So I will write here path of unit positive charge is electrical line of force. Line of force. So point to remember, path of a unit positive charge is electrical line of force. And unit positive charge, when we speak unit positive charge, unit positive charge, that is 1 Coulomb charge in MKS and 1 electrostatic unit of charge. 1 electrostatic unit of charge in CGS units. I will slightly modify the statement which I have earlier written. This statement will be more elaborate, that 1 Coulomb, that is taken as nearest approximation 3 into 10 to the power 10 ESU or 10 to the power 9. ESU of charge. So it is rather more elaborate, 1 Coulomb 3 into 10 to the power 9 ESU of charge. Then if you wanted to find 1 ESU, then these numbers are taken in the denominator and 1 ESU can be written as, that is of the order of 10 to the power minus 10. So I think these definitions are clear to you. Unit positive charge means 1 Coulomb or 1 ESU charge, and 1 Coulomb means 3 into 10 to the power 9 ESU of charge, and path of a unit positive charge is called electrical line of force. Positive charged bodies deficient of electron, negatively charged bodies has excess number of electrons. Another thing, the region around a charge, region around charge, region around charge in which electrical lines of forces electrical lines of forces show their effect show their effect. Electrical lines of forces show their effect is known as electric field. That is represented by E. When we speak electric field, it will be a scalar quantity. Electric field will be scalar, but electric field intensity will be a vector. So point to remember, E stands for electric field. Electric field. That is scalar. But when you write arrow like this, it becomes a vector. Electric field vector. This is basically the force experienced by unit positive charge. So E here with arrow, electric field intensity. Electric field intensity. F is the force experienced by unit positive charge within electric field. So electric field intensity will be basically force, so this will be a vector quantity. So now the point to remember is the electric field, and it is the volume of the electrical lines of forces, and electric field intensity, that is the force experienced by unit positive charge, and that is called vector. So these are some basic definitions, you have gone through it. Now you will remember that there are two types of charges. One of the charges Q and other is called Q naught. The representation of the charge is either Q or Q naught. These are two types of representations. Q stands for source charge. Source charge. And Q naught, test charge. Test charge. So these are two representations, one is a source charge, other is test charge. Now point to understand is that this source charge, it can be stationary or it may be moving. When it is stationary, it has a different characterization, and if it is moving, then it is exhibiting a different property. So what is the point to note? Stationary charges constitute electric field. I will write it symbolically, that is QS. QS means stationary charge. So QS stands for stationary charge, and QS, that is source, QS. It is not moving, it is stationary. It will give rise to electric field. It will give rise to electric field. Or QS interact with electric fields. Stationary charges interact with electric field. So QS will give rise to field. Field will exert force. Force will be experienced by test charge. So test charge means Q naught. Q naught is experience force of electric field due to source charge, that is QS. So Q naught experience force of electric field due to source charge. The electric field of Q naught is delta E, and delta E is approaching to 0, negligible. But source charge QS, source charge has significant electric field, significant electric field, that is E. So now I will just brief it, conclude it, that QS generates field, field exert force, force is experienced by Q naught. So QS gives rise to E, E will exert force, force will be experienced by test charge, and test charge has no field of its own, it is delta E approaching to 0. So you remember that Q naught means its field is very small, delta E, and that is approaching to 0. Thank you.